Okay, so for this video, we are going to discuss our chapter 2, which is permutation and combination. And generally for this chapter, right, what we can discuss in this chapter is we will always teach students the, the general cases that we have. All right, general cases that we have, and then what is the method that you should use when you see these particular cases. But in exam, right, because the exam style question, it can be very different. Not to say different, they can have a lot of different conditions. So you need to know also how to apply all the knowledge that you already learned to apply on all those different conditions there. Okay, but for what we teach here is a general idea. When you see this kind of condition, then this is the method that you should apply. Okay, so again, if you want to make sure that you can score well for this chapter, you have to practice a lot. So usually I will tell students this is actually one of the killing chapter. That means a lot of students, they actually not doing well in this part. Okay, so maybe we can start first. All right. Okay, so for permutation and combination, I believe that most of you learned it before. And then for this video, of course, we will only focus on permutation first. So you need to understand the term, the meaning of the permutation, and so you need to solve some simple problems involving selection. Selection means combination. All right. And then for permutation, right, to able to solve problem about arrangement. So arrangement and permutation, okay, are related. So that means permutation will involve arrangement. And also you need to consider different cases, such as sometimes repetition is allowed, or maybe sometimes repetition is not allowed, or maybe there are some restrictions. Okay, like sometimes when you want to arrange maybe a few objects, there are some objects that must be always together, and there are also some objects that must be separated. So these are different restrictions that might be asked in the exam or maybe in the question. Okay, so for this video, we focus on permutation first. Okay, so again, let us start. For permutation, so when you see the word permutation, it actually means that any arrangement, so the keyword is arrangement, okay, of those objects in a definite order, so the order is important. All right, so as an example, if I tell you that, okay, I have letter A and also letter B, two letters, right? Okay, so I'm having two letters. Okay, so if let's say I'm having letter A, I write it as AB and I write it as BA. This one considered as two permutation. There are two different arrangements, right? So that means we call it as two permutation or two number of ways, right? Okay, so here we take the example ABC also. Okay, so for ABC, if you want to arrange the letter ABC, one of the method is, of course, you can arrange it yourself. Okay, one by consider all the cases if you can. So if you arrange all the pattern already, then you can see how many numbers are, how many different types of arrangement are there. So you have 1, 2, 3, 4, 5, 6 different arrangement, right? So the permutation is equal to 6. And then if you want to arrange A, B, C, and D, then of course one of the ways is you can write it out. But this method is very, it's not good, I can say, because you need time to list out all the result here. So you can see that for 3, you are having 3 letters, you're having 6 different patterns already. So can you imagine or not, if let's say you are having 4 letters, how many arrangement will you have? Okay, so if you try to arrange, you will see that there are a lot, and then it is very time consuming. Okay, so this one I just list out 6 of them. Actually, in total, there are 24 of them. Okay, so you can see that if I want to list out everything, then it will be very time consuming. Therefore, this is not a practical way for us to calculate or get the permutation value for some certain objects. Okay, so the first method is list out all the arrangement, which is not practical at all. Therefore, they actually realize that if they try to look for the 3 letters here, A, B, and C, when we want to arrange them, right, they put 3 space, or maybe the 3 boxes here. And then for the first box, they will think of, okay, what is the letter that you can put in here if you want to put in only 1. So there are 3 possible results, right? You can have A, you can have B, and you can have C. Therefore, you have a 3 here. let's say you already put in one of the letter, so 2 letters remaining, and you want to put it into the second box or second space. Therefore, only 2 letters available now, and after that, you have 1. So they realize that when you multiply everything together here is 3 times 2 times 1, which is tally with the result that I did out just now. Okay, all right. Therefore, they know that if you want to arrange 3 letters, then you have 3, 2, 1. If you want to arrange 4 letters, then you will have 4, 3, 2, 1, and so on. Okay, so here they come up with the very first formula. That means if you want to arrange n items, then the answer will be n factorial. So n factorial means that start from n and then the number of you multiply with each number that's 1 below the previous one and then until 1. So as an example, if let's say they are talking about 5 factorial, let's say 5 factorial, what does it mean? It means 5, 4, 3, 2, 1. If let's say they say 10 factorial, then that means what? 10, 9, 8, 7, 6, then 5, 4, 3, 2, 1. As long as you continue everything until 3, 2, 1 will do. Alright, so this is what we have for factorial. So this is the very first formula for the permutation. So to arrangement of distinct item. So now I need you to highlight the word distinct. Okay, so the word distinct item means that different items. Okay, different item or not identical. Okay, so the not identical item or distinct item or different items, when you want to arrange n of them, so we call it as n factorial. You can press calculator straight away to get the value for n factorial. Okay, you can figure it out. I think if I'm not mistaken, it should be shift then something, but I forget what is the icon already. Okay, you can try to figure it out yourself. All right. Okay, so why must be distinct? Distinct means that different, because you see A, B, and C, then only you have 3, 2, and 1. Because if you're having A, and C, and when you want to arrange it, right, there might appear some arrangement here, which is repeated one, because you have 2A here, right? Okay, so for something that is repeated, we will have the method later. All right, but for now, the very first method is to arrange all the different items. If let's say you're having n different items, so the formula will be n factorial. If you are having 5 different items, then the formula will be 5 factorial. Okay, so let's have a look and see how are we going to apply all this up in our exam style question. Okay, so first they give you the letter of the word Cambridge. Okay, so C-A-M-B-R-I-D-G-E. So you can double check and see. The word Cambridge consists of 9 letters, and every 9 letters here are different. There's no repeated letters, right? Okay, so first they are asking you how many arrangements are there. So for part A, you can straight away tell them what is the number of arrangement. You are having 9 letters, right? Therefore, the number of arrangement will be 9, then factorial. Okay, so eventually what is the answer that you get? 362880 if you press calculator. Okay, all right. Now after that, for part number B. So for part number B, they give you a small restriction here. How many arrangements begin with CAM? Okay, so they want the arrangement to begin with CAM. That means the CAM is fixed. You are not going to touch it. You are not going to arrange these 3 letters CAM. So it is fixed there. So what are you going to arrange is the remaining 6 letters at the back, right? Okay, because total you have 9 letters, right? So the CAM is fixed in front. Therefore, you still have remaining 6 letters at the back. So to arrange these 6 letters here, and all the 6 letters here are different letters, right? Therefore, the answer should be 6 factorial, which is 720. Okay, so this is how we apply the formula here. Okay, all right. So this is for n distinct items. All right. Okay, so next one. Okay, there are some useful examples or maybe some useful formula on factorial. As an example, n plus 1 factorial can write it become n plus 1 multiplied with n factorial. If let's say you don't understand what does it mean, then you can do it like this. Okay, so I'm having 8 factorial. Okay, so 8 factorial, what you can do is that you can write it become 8, 7, 6, 5, 4, 3, 2, 1, right? Okay, and then you can actually rewrite the 7, 6, 5, 4, 3, 2, 1 become 7 factorial. And then the 8 is remaining 8. So it will become 8 multiplied with 7 factorial, which is equals to 8 factorial. So which is the same like you assume that the 8 is n plus 1. So this one is n plus 1, and then this one is n factorial. Okay, all right, so that's the meaning of it. I don't know when we will apply it, but it will be good if let's say you can learn it first. Okay, so the same thing happened here. n plus 3 factorial divided by n plus 1 factorial. You can write it become n plus 3 multiplied with n plus 2. So again, if you don't really understand what does it means, you can use a number line to help yourself to understand it. Okay, so let's say I give you another example here. Let's say I'm having 8 factorial divided by maybe 5 factorial. Okay, because if let's say you have 5, 5 plus 3 is 8, then 5 plus 1, sorry, it should be 6. So 5 plus 1 is 6. That's 6. Okay, can I? All right. So now, what do we have for 8 factorial here? So 8, 7, then 6, 5, 4, 3, 2, 1. So 6, 5, 4, 3, 2, 1, I write as 6 factorial divided by 6 factorial at the bottom. So you can actually cancel it off and you take 8 multiplied with 7. So you get 56. Okay, so this is how we apply all the simple formula which is about the factorial one. Yeah, all right, so again, the very first formula is when you want to arrange n different items, then the formula will be n factorial. Okay, so like just now we said about there are some items which is not distinct. That means there's no difference one. Okay, or usually we will say as identical items. No difference or identical items. Then generally, when you want to calculate the number of arrangement, right, the formula should be n factorial, which is the original number that you have, divided by p factorial. P is the number of repeated values or the number of repeated items. Okay, then if you're having more repeated item, then you can have n factorial divided by p, q, r factorial separately. Okay, so the p, q, and r are the number of repeated items of different types. Okay, so this is how we arrange the item which is not identical. Okay, so again, let's have a look for example 2. Okay, so for example 2, they are talking about the number of different arrangement. So when you see the word arrangement, generally you know that it should be belongs to permutation. Arrangement is the keyword that tells you this is actually a permutation question. Okay, all right, so using all the 10 letters of the word statistics. Okay, so they want you to arrange all the letters here. There are 10 letters here like statistics. Okay, but if you look at the letters inside, there are some repeated letters, right? Okay, so maybe you can list it out if you. How many repeated for S? How many repeated letters for S? Okay, so you're having 3S. Okay, and then how many repeated T that you have? You are having 3T in third. How many I do you have? You have 2I. Okay, then the rest will be something not repeated anymore, right? Okay, so to get the number of arrangement, formula is what? Originally you're having 10 letter, therefore it is 10 factorial divided by, because of in your arrangement, right, you are having 3S, 3T, and 2I. Therefore, when you write it out, it should be 3 factorial, 3 factorial, and 2 factorial. And end up, you'll get the answer, which is 50400. Okay, so maybe you can put in some small detail like this one. What is this? You are having 3S. Therefore, you have to divide it by 3 factorial. And then this one, because you're having 3T, therefore you have to divide it by 3 factorial also. And for this case, it is for 2i. Okay, so in general, in your question, right, as long as you see something that is identical or maybe something that is no difference, then you have to apply this formula. That means that you have to divide the numbers of the repeated items, okay, for each type of them. Yeah, all right, so this is what we have for our first two arrangement formula. So the first one is no difference for all the items. Oh, sorry, the first part is all the items are different one. Okay, there's no repeated item. Then the second formula, like what we learned just now, is you have some repeated item. So we're having two different formula now. Okay, then we proceed to the next part. Okay, sometimes in the question, right, they will give you some restrictions. Okay, they will give you some restrictions actually, all right? So to see the restriction, there are two cases. I separate into two cases here. The first one is when there are some items have to be together or next to each other. This is the keyword. And for case number 2, I will say it as the item must be separated. Okay, so in our notes, okay, I am not able to describe in detail when you see this kind of case, how are you going to do it? So we can just try to discuss and understand the whole process by using some example. All right, so I will just show you here for example 3. So example 3, they are talking about next to each other question. Okay, so let's start. Okay, so you're having 11 CD. Okay, highlight the word different. So although you're having 11 CD, but them are different. So there are 6 pop music. Okay, so 6 pop music, all the pop music are different. So that's why they say as different CD, right? So 3 are jazz, and then 2 are classical. Okay, so for pop music, I label it as P. Jazz music, I label it as J, and then classical, I label it as C. Okay, so they're asking for different arrangement of all 11 CD on the shelf. Are that if, first, there are no restrictions. So if let's say there are no restriction, means that the very first case that we learned before, you want to arrange 11 different items or 11 different CD. So what do you have? You're having factorial, which is 11 factorial, and you'll get the answer 39916800. Okay, so again, the word different is very, very important. Okay, then for part number 2. All right, so for part number 2, they are saying that the jazz CD are all next to each other. So they want to arrange all the jazz CD together, then the other thing can be mixed up, right? Okay, so now this is the very first example they want to discuss that for the cases where there are some object need to next to each other. Okay, then how can we solve it? Okay, so please have a look here. Generally, when you see something need to be next to each other, right? Like this is jazz CD here, right? So for me, I will usually draw the jazz CD. There are 3 jazz CD, and then I will put them in a box. So that means I assume that these 3 jazz CD is actually one object only. Yeah, you have 3 CD, right? But assume that it is only one, not 3. Okay, because they want to be next to each other, right? So this is the first step that you need to know. And then after that, you're having 6 pop CD, 1, 2, 3, 4, 5, 6, and then 2 classical, 1 and 2. So please take note that all the CD here are different. Okay, then now I want to arrange them. So what's the process? Just now you already put the J in one group, right? So that means this is 1. Hey, how many items you have now? 1, 2, 3, 4, 5, 6, 7, 8, 9. So you're having 9 items now. Therefore, it is something like you are arranging 9 different items, so which is 9 factorial. Why 9? Because there are 3 just in here. I already grouped them become 1 unit. Okay. All right. So this one haven't finished yet. So after you multiply overall 9 factorial, then now you have to look into the boxes here. For the item that need to be next to each other, they can also arrange between them, right? J1, let's say I'm having J1, J2, J3. You can also have J2, J1, J3, or maybe you can have J1, J3, J2, and so on. So you still need to consider the arrangement in this bracket or maybe in this group. So how to arrange 3 items? Okay, so it is actually 3 factorial, and this is 3 different items. All right, so you should have 9 factorial multiply with 3 factorial. Why multiply? Because multiply everything, right? Only it is the complete original 11 CD that I have. If you only have 9 factorial, that means you only consider the 9 items here. I have to consider everything complete. So you have to multiply with 3 factorial. Okay, so if this one, if you didn't do any careless mistake, then you should get 2177280. Or you can change it become 3 significant figure 218000. Okay, right. Then now, hopefully you have the idea how to arrange the CD that something need to be next to each other. Okay, then let's continue. If the CD of the same type are all next to each other, so now they further restrict it. So they want all the same type are next to each other. So that means all the jazz CD in one group. Okay, so all the pop music in one group and also the classical CD in one group. Okay, so now you assume that you only have 3 items here, which is 1, 2, 3. So you want to arrange these 3 items, that means it is 3 factorial. And then after that, you need to consider the arrangement in the jazz CD. So having 3 jazz CD, that means you have to multiply it with 3 factorial. Same thing happens for the pop music. You're having 6 pop music here. Therefore, when you want to do the arrangement, it should be 6 factorial. And the last one, you have to consider the arrangement in the classical CD. So it should be 2 factorial. So you multiply all of them to get the answer. So what is the answer here? The answer here is 51840. Okay, so I hope that you all can see the pattern and the way that I try to arrange the items which they need to be next to each other one. So this is how we do it. Okay, all right. So that's why it's very hard for me to list out the steps in detail. So generally, this is how I do it. So every time I see this kind of question, I will group them together, become one item first. Okay, then after that, after I arrange everything, only I come back to this group to arrange themselves. All right, so this is how we do it. Okay. All right, so if no problem, you can continue further. Let's have a look for example 4. It is still case number 1, that means something need to be next to each other. Okay, so let us start. You have 7 friends with their respective partner all meet up for a meal. So to commemorate the occasion, they arrange for a photograph to be taken of all 14 of them standing in the line. Okay, so first, they are saying that how many different arrangements are there if each friend is standing next to his or her partner. Okay, so that means on now, all the friends, right, they are standing in couple because they want to stand next to the partner, right? So that means, the friend number 1, A1, standing together with the partner A. Then when you have the next friend, right? So next friend B1 standing with the partner B2, and so on, because they must next to their partner, right? So you can actually make sure that, okay, he or she with her partner or his partner, okay, are in a group. Okay, so E, then F, then G. Okay, so I'm having 7 groups here. Correct? Not 7 friends, my 1, 2, 3, 4, 5, 6, 7. So I assume that all the 1 are the friends. So all the 2, A1, A2, B2, C2, D2, and so on are actually their partners. Okay, so they want to stand next to his or her partner. This is how they stand it. So overall, you look for overall. Okay, how many groups do you have here? Okay, so you can see that you're having 1 group, 2, 3, 4, 5, 6, 7. Therefore, you're having 7 groups. Okay, and then each of the group, you also need to consider the arrangement inside, right? So you have 2 factorial. Then this one is also 2 factorial. This one also 2 factorial. 2 factorial. 2 factorial. 2 factorial. 2 factorial. Okay, so this is how we do it. Because the couple, they can also exchange their position, right? So consider every single cases also. So you have to multiply 2 factorial for 7 times. And then if you didn't do any careless mistake, you should get 6, 4, 5, 1, 2, 0. All right. Okay, then part number 2. How many different arrangements are there if the 7 friends all stand together and the partners all stand together? So again, now they try to arrange in this way. They want to have all the friends are together. So just like I told you, right, the number 1 are all the friends are. So A1, B1, C1, D1, E1, F, and then G. So all these are in one group. All the friends are in one group. And then after that, you're having A2, B2, C, D, E, F, G. So again, this is another group which is formed by their partners. Okay, so overall now, how many groups do you have? You're having 2 groups here, right? So this is number 1. This is number 2. Okay, so for number 1, so you're having 2 groups, so you multiply with 2 factorial first. And then for group number 1, all the members inside can change their position. So that means you're having 7 factorial. And then the same thing happens, okay, for the group of partners. So also can multiply with 7 factorial. So when you try to multiply everything, then you should be able to get 50803200. Okay, so this is what we have for the very first case when you want to arrange the item next to each other. Okay, all right, so I hope that you remember the method, and then once you see you get this kind of question that need to arrange together one, then this is the method that you apply. Yeah, all right, then next one. Okay, so for next one, example 5, 6, 7, and 8, all of them are case number 2. Case number 2 means that something must be separated. Okay, so usually when we want to do something must be separated, right? What are we going to do? Okay, so this is how we do it. There are 8 soprano in a choir, and then there are 2 person and 2 girls here, Ruby and Grace, refuse to stand next to each other. So how many different arrangements can there be? Okay, so Ruby and Grace must be separated. So for this kind of question, what we do is like, you ignore the Ruby and Grace first, you arrange the rest of the people first. So as an example, you are having 8 people, so 1, A, B, C, D, E, F. So you have 6 people here, then add on Ruby and Grace. So 6, 7, 8. So in total, you're having 8 people. Because Ruby and Grace, they don't want to stand together, so I arrange them at last. So now I arrange the remaining people first. So the remaining people, there are 6 of them. 1, 2, 3, 4, 5, 6, right? Okay. Therefore, you will write out 6 factorial first. And then after that, you can try to look at Ruby. Now I want to place Ruby already into the group, into the line. Okay, so for Ruby, you have how many space to put her in? 1, 2, 3, 4, 5, 6, 7. So there are 7 places for you to put, so you can put 7. Then multiply with, okay, let's say you put Ruby here already lah, just now in this space already. So this space is no longer available anymore. Then now you want to place Grace in the group. So how many places are available, space are available for Grace? So you can count also 1, arrow 1, 2, 3, 4, 5, 6. So you're having 6 for Grace. So 6 factorial multiplied with 7 times 6, then you will get 30240. Okay, and then before I forget, please take note that for this example, some of the reference book, they will tell you that you can write it become 6 factorial and then 7p2. So 7p2 means that you want to arrange 2 people into 7 spaces. So you can write as 7p2 or 7 times 6 also can. Both are the same actually. So you will get the same answer. Alright, so this is what we have. Okay, hopefully you have the idea roughly. Okay, alright. Then now let's continue to example 6. Okay, so you're having A, B, C, D, E, F, G, H. Okay, so how many different arrangements? So again, you see the keyword arrangement, then you know that it is permutation. Okay, so first they say A, B, C are not next to each other. Okay, so not next to each other means they must be separated for the A, B, and C. So which means you arrange all the other letters first out. You say D, E, F, G, H. So to arrange these 5 letters here, it should be 5 factorial. And then now you want to put in A, B, and C. So for A, how many spaces you have? 1, 2, 3, 4, 5, 6. You can write as 6. Then for B, you erase 1 space. Okay, so you left 5. And then for C, you left 4. Okay, so if you continue to calculate this answer from here, you will get 14400. Okay, or another one is you can write also 5 factorial multiply with 6b3. That means you want to arrange 3 people into the 6 spaces. So it should be 6b3. You will get a answer. Okay, so you can see that we arrange the letters that want to be separated one at last. Lastly, only you arrange them. Okay, then for part B. So for part B, they said A, B, and C are not all next to each other. So when you look at this one, it is a bit confusing, but no worry. I will ask you to cancel off the word not first. Okay, so what is this about? So they are talking about A, B, and C are all next to each other. So if all next to each other means what? Means that A, B, and C must be together. Then D, E, F, G, H can be separated. Okay, so to arrange like this, that means A, B, C must gather. How can I do it? So again, how many items do you have here? 1, 2, 3, 4, 5, 6. So you're having 6 items here, therefore you should have 6 factorial first. Okay, then after that you need to consider the arrangement in the group itself, right? So the A, B, C here, you can write it as 3 factorial. Okay, alright. So for this answer, 6 factorial multiplied with 3 factorial, it is for the case all next to each other. Okay, all next to each other. But now I clear up, okay, the shaded area here, and you see that they actually now not all next to each other. So this is next to each other, right? Not all next to each other means what? You have to take the total. So total arrangement without restriction means 8 factorial because you're having 8 letters here. So if there's no arrangement, no restriction when you want to arrange the 8 numbers, different numbers will be 8 factorial divided by 6 factorial and also the 3 factorial. So from here you'll get 6, 36 All right. Okay. So this is how we do it. And then for this part B, it's a bit tricky, the way that they are asked to answer, the word that they are using. But again, please make sure that you understand what they want, because they might come out again in the real exam. Okay, so next one. Okay, so example 7. Okay, so they started to bring all the things now. So please be aware of that. Okay, so there are 3 identical cans of cola. So cola, 3 identical cans. Then 2 identical cans of green tea. Then 2 identical cans of orange juice. Okay, so and they want to arrange in a row. So arrange means that involve permutation. Okay, so first, they are saying that the first and the last can in the row are the same type of drink. You have 3 types of drink, right? Okay, so now they want to make the cases that the first and the last can in the row are the same type of drinks. So maybe you need to list out the case. So for case number 1, you can make sure that first can is cola, then the last can is cola. Okay, then the second case is what? The second case is you can make it like first can is green tea, the last can is also green tea. Okay, and then for the third case, first case is orange juice, the last can is also orange juice. Okay, so the remaining space that you want to arrange inside is 5 because total got 7 drinks, right? Okay, so you can fix this one. Fix the C, fix the G, fix the O. That means all the C, G, and O for the first and also the last can, you are not going to move them at all. Okay, so we are not going to move them. Therefore, we didn't consider it. Okay, then now, for case number 1, how many cans of drinks you still have in the center here? There are 5. So maybe I want to list it out in detail. How many things you have here? You have 1 cola, 2 green tea, and then 2 oranges. 1C, 2G, 2O. So in total, there are 5 items of them. So to arrange these 5 items, what do I have? Okay, 5 factorial. But there are some identical items inside, right? So that's why you have to divide it by 2 factorial and also 2 factorial. So this is the answer for case number 1. Okay, for case number 2, if let's say first can is green tea, last can is green tea, then how many drinks you still have? You still have 3 cans of cola and also 2 cans of orange juice. So if you want to arrange this, total you're having 5 items, so 5 factorial still, and then 3 repeated cola, so 3 factorial divided by 2 oranges, so oranges, so divided by 2 factorial. So this is the answer for case number 2. For case number 3, both are oranges, right? So you still have 3 cola and 2 green tea. So the answer should be the same as the previous case. So factorial divided by 3 factorial divided by 2 factorial. Okay, so after you calculate case by case, then what you need to do is you total them up because they are different cases, they are separate cases, right? So this is complete one case, this is the second one, this is the third one. So to get the idea, the total, so you have to add that all, which is 50. Okay, can all right, so this one involves repeated idea. Okay, and this is a repeated idea generally, but you need to solve it case by case. Then now you look at case number 2, part number 2. The 3 cans of cola are all next to each other. So maybe I group the cola in one group first. The cola are all next to each other. Green tea, not next to each other. So that means green tea, you have to arrange them at last. Okay, so besides the cola, I still have orange juice. Okay, so let's start now. How many items do you have here? 1, 2, 3. Okay, therefore, when I write out, it should be 3 factorial. Okay, then just like I told you, right, you should consider the cola, the arrangement of the cola in the group. Clear or not? Okay, so we want to arrange these 3 cans of cola. What do we have? You are having 3 factorial. Okay, but these three columns, they are identical. Because they're identical, therefore when you divide, when you want to arrange it, you also need to divide it by 3 factorial, the repeated case. Okay, so 3 factorial divided by 3 factorial is equals to 1. So you might see that sometimes some reference book, they will not write out the step here. Okay, but to me, I want to show you what have I taught you just now. So I want to apply it here. Therefore, you can see that I'm applying something that I teach you just now. You're arranging 3 items, so 3 factorial. But these 3 items are repeated, therefore I have to divide by 3 factorial as well. Okay, so after you're done with this, then now you need to consider the green tea. So how many green tea do you have here? 1, 2, 3, 4. You have 4 space for 2 green tea, right? Okay, so first green tea you can put in 4 space, one of the 4 space. The second green tea you can put in left 3 space only for the second green tea. And then after that, you need to divide it by what? So you need to divide it by 2 factorial. Why do I need to divide it by 2 factorial? It is because of the repeated green tea. Okay, so just now I forget divided by 2 factorial also. Why? Because when you arrange the 3 items just now, 1, 2, 3, okay, you are having 2 repeated O, oranges. So this is for 2O. Okay. And then this is for 2 green tea. Alright, then the blue color part, if you don't want to buy, is okay lah. Okay, then eventually what you get is you will get 18. Okay, can? Alright, next. Example 8. Okay, so for example 8, what do we have here? Okay, so the word Argentina includes the 4 consonant R, G, N, T. 3 vowel is A, E, I. Okay, so first, I want to calculate the different arrangement. So you know it's permutation in all 9 letters. Okay, so from this 9 letters, I want to know first, is there any repeated letters or not? I think so, right? How many letter A you have? You have 2 letter A. What else? I think you have 2 letter N, right? That's all. Okay, so 2 letter N and also 2 letter A. The rest are all 1. Okay, so now you want to arrange 9 letters. So 9 factorial. How many repeated letters are there? You have 2 N and also 2 A. So you have to divide it by 2 factorial and 2 factorial. Then this is the way that you get the answer. Okay, then after that, let's continue to part number 2. Okay, how many of this arrangement have a consonant at the beginning, then a vowel, then another consonant, and so on alternately? Okay, so when they want to have alternate arrangement, consonant, vowel, consonant, vowel, consonant, vowel, right? The idea generally is the same as the object that must be separated. So you can see like, okay, how many consonant I have? R, G, N, and T. Okay, and then they want to start with consonant first, and then after that here you put in the vowel like A, E, I, or you can arrange them. So for this one, it is fixed that consonant must be at the beginning first. Okay, now I want to arrange the consonant first, R, G, N, and T. So to arrange these 5 letters here, it should be 5 factorial and divided by 2 factorial. I hope that you know why I need to divide it by the 2 factorial here. Okay, when you want to put in the vowel, we are having 4 vowels here. Okay, if you want to have 4 vowels, you cannot include the space outside. Because if you put some vowel outside, right, then maybe E and I are here. Then you will see that their 2 consonants will be together. Because here they want to have consonant and vowel alternately, right? Okay, therefore, the space outside will not be considered. Okay, I only consider the space inside. So how many space you have here? 1, 2, 3, 4. So these 4 spaces you want to arrange in the 4 items, 4 vowels. So you're having 4 factorial, but I need to divide it by 2 factorial. So again, why do I need to divide it by 2 factorial? Because you're having 2/8 in the vowel. All right, so eventually, if you press calculator, then you'll get 720. So this one, you need a little bit of common sense. You need to know that you cannot put any vowel outside. Okay, so you shouldn't consider the space outside because it will not be enough to make the letters arranged in consonant and vowel alternately. Okay, so this is something like I tell you, we might not tell you about all this, but when you apply it in the question, you need to think a little bit more by yourself to see which is how should you apply it correctly. All right, okay. So from here, example 1 and example 8, there are 4 cases actually. The first one is the arrangement without restriction. The second one is arrangement with repeated or non-distinct item. Then the third case is one of the restrictions that we learned is some item must always together next to each other. Then the last one is some item must be separated. So generally in exam, they will ask very often all the 4 patterns here. Okay, so for the solution that I solved you from example 1 until 8, please think that they are not the only solution. That means this is not the only way for you to get the answer. Some reference book, they will recommend or suggest some other methods, which is also correct one, not wrong. All right, but for me, because what I'm going to do here is I will always use back the same method to solve the same pattern. Okay, so that you won't feel confusing. Because last time got show me also like, okay, this question why I cannot do it like that. He's not using my way. So again, actually you can do it. But for the method that he's using, right, when they started to change a little bit of the structure of the question, then he might feel confusing because he need to think more. Okay, so for the method that I developed here, that I show you here, generally is, to me, like comparatively is easier. That means once I look at this pattern of the question, then I apply the method. Okay, it's more straightforward. Instead of you think of a lot of different things, there are others actually. Okay, but to me this is easier. Okay, so again, example 1 until 8 is all the restriction that I mentioned just now. There are 4 types. So I will skip example 9 until the later video because this involves other restriction. And I think we might learn it maybe after we learn more other concepts. Okay, so for this video, I want to stop at example 8 only. Again, to make sure that you can handle all this very well, you have to practice a lot. Alright, because I understand the feeling. Because when we discuss it in class, or maybe we discuss all the examples together, at least you roughly know, okay, I know that I have to apply like this and like that. But when you try the question paper yourself, you might find that you stuck halfway, or maybe you actually don't know how to do. But you must try to write out something first, try. Then if really cannot get an answer, you look for the marking scheme, and please check and explain why the marking scheme do the method like that. Then you learn from there also. Okay, for this chapter it is a bit special because to me it is quite hard. Alright, so I'll stop here for this video, and then in the next video we are going to discuss more example and more methods. Alright.